All right, I want to thank you guys for coming to our webinar. It's the What's New with Dell and NVIDIA for SOLIDWORKS. And presenting today is Scott Hamilton from Dell Technologies. He's the industry strategist for engineering and manufacturing. And I'm Steve Darcey, electrical product manager and elite applications engineer for SOLIDWORKS. CATI, so I want to kind of start up with a little bit about GoEngineer, and then we'll get into some of the whys of why you need new hardware. And then we'll let Scott go in and tell you exactly what type of hardware you might need. If you're with CATI, you're now part of the GoEngineer family. So we welcome you. All of the great folks that you had at CATI are now with GoEngineer, and just same great people, different name. What that does is it expands our territory. So we're now fully East Coast and West Coast. So if you do have different locations across the US, we can now be your strategic VAR for all those products. So some of the products, of course, that we carry are mainly the SOLIDWORKS products, but we have some other products as well. We handle all the PDM management, simulation, sustainability, technical publications, and mechanical and electrical design software. We also do some 3D printing. So we have some services for FDM, resin-based, PBF, and metal printing. On the metal side, we carry the Velo 3D printer and the Exact Metal. Each of those have different reasons why you might want one versus the other. Also, depending on what type of material you're printing, we may use one or the other. We also do 3D scanning. We do the RTX scanner and the Creaform scanners. So we're trying to be the one-stop shop for scan it, pull it in, model it, make changes, and then also some of the rapid prototyping with 3D printing. All of those products, we do services and training on those. We could do that through a web, classroom, custom on-site training if needed. We also do certification training. And then we also do support. Some of the products that we have are self-based, which means you just pretty much watch a video and then try and follow along. With the support and services, we have world-class tech support. We also can do mentoring sessions. And we also have a customer portal where you can get online, create technical support tickets, and we also have a community or a forum that you can post stuff. So now getting into why you might need to upgrade your software or your hardware. One is large assemblies. Every year in SOLIDWORKS, so this year we just released SOLIDWORKS 2023, Service Pack 0.1 is out right now. So you can download it if you're on subscription and install it. And we try and have better performance and stability in each of the products that we carry. And but there is a part where, I'm going to talk briefly real quick on large assemblies, is your open and save times, your rebuild times. And sometimes a large assembly may not be a lot of parts, but it may be very complex parts. So I got a very complicated part up in the top right corner. You can kind of see that. But there becomes a time where there's only so much you can do if you have a 1,000-part assembly versus a 10,000-part assembly. Well, if all of those parts are unique, then we still have to load those in one at a time. And so for large assemblies, a lot of it is high-speed single-core processing, especially on rebuild times. We have to rebuild the browser tree of a part just one feature at a time. We got to update the sketch, update the feature, update the sketch, update the feature. And then once we're done, then we of course have to render that thing out and make sure that your graphics card can handle that. So, the faster the hardware, the faster the CPU, the memory, the graphics, and especially the hard drive and motherboard. I didn't add that in there, but all of that comes together to make, a seamless machine that hopefully can process stuff faster than the previous machine. So there does become a time where you can only do so much with an older system and the software, and so sometimes you just got to upgrade. All right, some of the things that we've had here is some of the images are done with Visualize, and Visualize is our product for realistic real-time rendering. So you can see the shadows and the ray tracing and everything look really good. and I've got a little video. In 2023, we now have we've had the NVIDIA iRay and the AMD Radeon Pro Render, but there's a new 3D Stellar Physical Correct Render that's from 3ds. And it allows the pretty much the metallic colors and stuff to actually look really, really good. And Visualize is a CPU and GPU rendering tool. And so when you set that up, you really need a high performance system to be able to do these renderings real time and make sure you get exactly what you want before you hit that render button. Another thing that's very hardware specific is going to be the simulation tools. At GoEngineer, we handle the SolidWorks products. We have a simulation standard, professional, and premium. And then we get into the CFD, the computational fluid dynamics, with FlowSim, electronics cooling, and the HVAC modules. We also do the plastic injection molding, which is a portion of the Simpo just running inside of the SolidWorks as an add-in. And then we have some really high-end Simolia packages for the Abacus solver. And some of those you can get those online, but we also sell those to where you can install them on the local machine. So here I have you think about things all around, everybody's wearing t-shirts and pants and things like that. So sewing machines, I've got a little sewing machine here. And occasionally, you may have things break, but it's better to figure out what's going on with them in 3D and try and solve a solution to make sure it's not going to break before we actually build it. And one of the cool things in SOLIDWORKS 2023 is, of course, we've sped up the ability to solve things. So, not only is the new software going to be a little bit faster in this release, but of course, if you get new hardware, it may be twice as fast. All right, and then here's some really high-end FEA analysis modules, some nonlinear. Here you can see the actual thing breaking. So that's with the Abacus solver. You can see all the stresses flowing through that material. And then, of course, any simulation for plastic injection molding or flow analysis is going to be highly, highly computer intensive. So the more CPUs, the merrier when you get to the flow analysis. All right, so that's kind of the question as to why do you need maybe a new system. So let's go ahead and move on let's switch over to Scott, and he'll explain the different solutions that they have to.
Hey, good afternoon, everybody. My name's Scott Hamilton. As Steve mentioned, I'm an industry strategist for Dell. I work in our performance PC group, which is the division that sells workstations. And those products are the ideal products for SolidWorks users, for engineers and stuff that are really looking for high performance systems to use with their applications. So let's jump into the presentation. Just get my screen sharing properly. All right, can you guys see that?
Yeah, it looks good, Scott.
Okay, thanks, Stephen. Okay, guys, I wanted to take you through a couple things, talking about typical workstation workloads, and then we'll talk about configurations, what we recommend for SolidWorks and some of the pros and cons. And then at the end, we're going to talk about some extra special deals that we're offering to GoEngineer and CATI customers. So stay tuned for the end. So let's talk about the typical workstation workloads. Many of you may be familiar with some of this, but when we design our workstations, we really consider two different type of workloads that people are typically using on their workstations, and that's what we call interactive workloads and computational workloads. And let me kind of define what they are. Interactive, it's pretty descriptive in the word interactive. So this means when you're interacting with your system. So when you're inside of SOLIDWORKS and you're, building, designing a model, and you're editing parts and you're spinning around the view and things like that, that's what we would consider interactive, because you're actually, doing input into the system, or you're viewing it. And so when you're in the process of doing design, or another good example of that is visualization, especially VR. So if you were wearing a headset and looking at your model in VR, which you can do with some SOLIDWORKS applications, then you're constantly interacting with the workstation by changing the view and where you're looking at that model. So that's what we call interactive, as opposed to computational, which is usually more batch processing. So that's where you start a process and you may walk away from your system because it's going to take a little while to compute that. And some examples of that would be, using SOLIDWORKS Visualize to do product rendering, or doing some type of simulation analysis, like using, SOLIDWORKS simulation to do structural analysis, or flow to do some type of computational fluid dynamics work. Those tend to be computational. Now, the major differences that we typically see in these workloads are kind of illustrated here in this radar diagram. You can see on the outside are all the major components of the computer, like the CPU, turbo frequency, core count, memory speed, memory capacity, etc. So a typical interactive workload will load your workstation, somewhat similar to this. Every application varies, of course. But when we look at typical interactive work, most of it is single threaded or very low threaded. Maybe it can take advantage of 2 or 3 cores. But because of that, turbo or CPU frequency is very important. The way we get work done faster is by making the processor run faster, not adding more cores to the process. And it's typically, there's a lot of GPU rendering involved there, because as you're modeling, you're updating the model in the screen, you're rotating it, and that, exercises the display capabilities of the graphics card. And then, of course, you have your memory speed. So as you're loading models, you're, loading that into memory and making changes. And then also you have, typically high sequential storage performance is required. And this is, when you're loading your model or saving it, which obviously, most users do that frequently, because they don't want to lose any data, or they're saving different versions. So this is the typical demands we see in an interactive workload. And now if we look at a computational workload, again, now we're doing some simulation work, and you can see the demands change dramatically. And CPU frequency or turbo frequency is always a good thing to have, but it becomes much more important now to have more cores, to get more CPU core count, because many of these operations are highly multi-threaded, and that can be on the CPU or on the GPU computational performance. And a really good example of GPU computational performance is SOLIDWORKS Visualize. That can be completely GPU enabled, and we can do all of the rendering on the GPU. But other operations like SOLIDWORKS simulations, flow, etc., are CPU bound, and they're going to perform better with more CPUs. And we'll talk a little bit about what's the right number of CPU cores there. And then also memory capacity is really important. GPU memory and regular RAM is important. And also usually memory latency is, because typically when you're running a simulation, you are having to load all the matrix operations in and out of memory quite rapidly, especially on larger data sets. So that becomes a very important aspect of the workstation. So as you can see, these workloads are very different. And it really depends on what you're doing on the system, and that's what I'm going to talk about next. When we talk about, a system configuration for a SOLIDWORKS user, these are the most important considerations. Number one, balanced, and that really goes back to the previous slide. If you're doing both computational and interactive work, then you need to look at a system that's very balanced as far as its capabilities to provide the best performance for both computational and interactive workloads. So this is something that's really, really important. Consider everything that you're doing, not only interactive versus computational, but what workflow are you using? What applications are you using? And I know, probably everybody on the call is using SOLIDWORKS, but you may be using some other tools as well. So make sure you're considering what the recommended hardware is for those other applications, and build a system that really is good for all of your workflows, all of your applications. So you don't, sacrifice anything. And I kind of equate that to, if you look back at an analogy for buying a stereo system right at home, you don't want to spend a fortune on a really nice receiver and amplifier and then, buy crappy speakers, right? You're not building a balanced system. So that's why you want to really consider everything. And again, we'll get into more details on each individual component. Concurrency is another important aspect. And when I talk about concurrency, what I mean there is, are there times when you're doing multiple things at once? For example, in SOLIDWORKS, you could set up a simulation and then kind of run that in the background while you try to do some more design work. Or you could run a SOLIDWORKS visualize render at the same time you're doing design work. And there are ways you can do that. We're not going to get into all those details right in this webinar, but consider that, if that's the workflow you want to use, then make sure, maybe you're getting a little bit more CPU cores than you normally would if you want to do concurrent work, or a bit more RAM, because now you're trying to do two things at once, right? And that especially applies if you're using multiple applications. You may be using some other application to do your structural analysis, or your CFD work, right? And you could run that at the same time you're running SOLIDWORKS. So we'll talk about that too in some of the recommendations specifically. And then also make sure you consider your future needs and expandability, okay? If you think your data sets are going to get larger in the future, maybe you want to buy more RAM right now, or maybe you want to make sure you just buy a system that has the capability to expand in the future, and you're going to add that RAM later, right? So think about those type of things when you buy a system. As you guys are probably aware, whatever company you work at, it's probably a lot easier, number one, to buy the right system from the get-go and not have to ask for, another system, in a relatively short time later, or to ask for an upgrade. But certainly probably easier to ask for an upgrade of some more RAM, a year later than, ask for a completely new system. So that's a really important consideration. So let's talk about what are the standard recommendations for SOLIDWORKS component by component. So let's talk about the CPU first. And the way I've tried to break this down is based on the different version of what you're doing in SOLIDWORKS, whether you're just using like the standard SOLIDWORKS to do design work. What if you're doing simulation, and then what if you're using visualize? Okay, so that obviously, going back to the interactive versus the computational, has a dramatic effect on, you know, what you want to buy. So if you're just doing standard design work, then really all you need is about 4 cores for SolidWorks, right? You're going to need, you know, 1, 2, maybe 3 cores for pretty much everything you do in SolidWorks. I always recommend, you know, at least an extra core or 2 to handle background processes in Windows. So really, all you need is 4 cores. Now, as many of you are probably aware, you probably can't even buy a workstation with 4 cores these days. You know, pretty much the minimum is 8 cores. So, you know, you're going to start at 8 cores. And we'll talk a little bit about this new Intel hybrid core architecture, but I'll finish the recommendation on this first. So if you're doing simulation work, then remember that computational workload will require more cores, okay? And I usually say about between 8 and 12. And to be honest with you, 8 cores is what you need to do your simulation work. But if you're going to do, you know, reserve a core or 2 for Windows background processes and then maybe try to run, you know, SolidWorks in the design, you know, mode at the same time, then, you know, you want to go to 12 cores. And then if you really want to get fancy and try to run multiple simulations at the same time, so you can, you know, set these up in SolidWorks and run them at the same time, then, you know, you want to consider, well, if I'm going to run 2 at the same time, then maybe I want 16 cores for simulation and another 4 to run SolidWorks Interactive. So now, you know, I'm up in the, you know, 20, 22, 24 core range that I might want to look at if I'm really going to push the limits there. And then visualize. If you're going to use visualize with GPU rendering, then you only need really, you know, 4 cores, just standard, you know, just the standard recommendation. Now, one note, I didn't really note it on the slide here, but there is a mode of visualize that you can use just to use GPU rendering or CPU rendering if you want, but I highly recommend you take advantage of the GPU rendering because it's going to go a lot faster. And we'll talk about some of the speed ups in that around that in a minute. So before I jump onto the next kind of component, I do want to talk a little bit about Intel, the new Intel technology. You may have heard of it. It's called hybrid core technology that was launched just recently with the Alder Lake processors, or 12th generation processors as they're known today. And of course, Intel has already announced their 13th generation processors. So those are coming right around the corner. But there's an important kind of differentiation here that you need to be aware of. So traditionally, Intel processors came with what are called now performance cores. And those are the standard processors that you probably have today if you have a machine that's less than a year old. All of your cores will be performance cores. But what they've done recently in this new hybrid core architecture is they've created a new type of core called an efficiency core. And those efficiency cores are designed to do lighter workloads, and they use a lot less power, and they generate a lot less heat. So they're really ideal. We talked about, well, if I was running SolidWorks, I might want, you know, just standard SolidWorks. I might want, you know, 1, 2, 3, 4 cores to run SolidWorks, and then an additional core to run those Windows background processes. Well, that's what those efficiency cores are really good at doing, running those background Windows processes. So what Intel has done with their new architecture is they've added efficiency cores into the package. So now it's not unusual to see a CPU with 12 cores or 16 cores maybe. And, you know, 8 of those are the typical performance cores that we want to use for are running SOLIDWORKS, whether standard or simulation, and then we have a number of efficiency cores that are great for handling those background processes. So just consider that when you're looking at the newer systems. Now, one thing I also want to mention, we're talking about the clock speed, right? And if you look on the SOLIDWORKS website, they'll always tell you get something that's 3 gigahertz or more, okay? And a note here, there's really 2 different types of clock speeds you want to look at. And actually, it's getting even a little bit more complicated with those efficiency cores being added. But typically, you're going to see on your performance cores, you have what they call a base clock speed and a turbo clock speed. And the base clock speed is kind of the minimum that the system will run at with all cores being active. And so that's important, of course, when you're running simulation, because that's when you're running all the cores. But when you're running an interactive workload, like in the standard SOLIDWORKS, then the turbo frequency becomes much more important, because what turbo does is Intel can automatically increase the clock speed of the cores on the system, especially when you're using less than all the cores. And this all comes down to the heat generation on the die of the CPU. So if you're only using 1 or 2 cores, it can bump up those cores to really fast, and some of the new CPUs can turbo up to like 5.3 gigahertz. So that's really nice. And this all happens automatically, so you don't have to worry about it. So if you're using standard interactive SOLIDWORKS, then it's going to automatically bump your clock speed up really high, 5 gigahertz or more, and you're going to get a very, very responsive experience, right? Which is perfect. But then when you start SOLIDWORKS simulation, for example, now it's going to utilize more cores and it's going to have to drop the clock speed a bit. The reality is the CPUs are getting so good, and the cooling systems that we build into our workstations allow you to, even when you run all the cores, you can run it above the base frequency. So you're still going to get this really good performance, and you really get the best of both worlds. You get turbo when you need it, and then you get cores when you need it with a little bit of turbo. So that's a really great thing about the new architecture of the Intel processors. Now, again, with the hybrid cores, there's a different base clock speed and a different turbo speed. They can't turbo as high as the P cores or the performance cores. But again, remember, those are used for the background processors mainly, so it's not as important. We're really focusing on the P cores. So that's kind of the considerations with a CPU. Now let's talk about RAM, or your random access memory. I generally recommend these days 32 gigs of RAM. You could get away with 16 gigs if you're using very small models. You could get away with it, but I don't really recommend it. You're probably going to quickly run into a model that you're going to need more RAM, and you're going to wish you had 32 gigs of RAM, and RAM's not that expensive nowadays. So I would recommend start with 32 gigs. Now, if you're going to start doing simulation work, then I would recommend increasing that, and that will depend on the size of your simulations, but I would probably go up to 64, and in most cases you're going to be fine. Again, if you're starting to do simultaneous simulations and doing multiple things at once, then you might want to consider going above 64 gigs of RAM, but that's not that typical. Also, if you're doing simulation work, I would recommend ECC memory. This is called error code correcting. And what that does is it gives you an extra level of assurance that there are no bit failures in your memory, which might impact the accuracy of your simulations. And it'll also help reduce potential blue screens where you have a memory bit that flips, and that can cause a blue screen. So the ECC memory, actually with the the Dell reliable memory technology will help you. And by the way, you get the Dell memory technology free with every Dell workstation. So that's a great little benefit if you have ECC RAM. And then for visualize, you don't really need, you know, much more memory than the standard 32 gigs, unless you were doing something very, very large. So the RAM's pretty simple. And remember when we talked about future expandability, you know, just keep that in mind. You know, if you know you might want to go up to 64 gigs later, there's two considerations. One, make sure you buy a system that can go at least up to 64 gigs. And, you know, pretty much all of our tower systems can. Some of our mobile systems would be limited at 32 gigs, but most of them can go to 64 or more. But some of the entry-level mobile systems can only go up to 32 gigs. So keep that in mind. And then also, when you buy your memory config, you know, look at that. So for example, the system that I'm just showing here, we can use an example. This happens to be a 3660, a Precision Workstation 3660. It has 4 DIMM slots, right? So if you were to buy this system with 32 gigs and you bought 8 4-gig DIMMs, you would fill all the slots, right? And the only thing you could do if you wanted to add more memory is pull out all that memory and put bigger DIMMs in there. So now you're kind of wasting the memory. You know, you can always take that out and put it in another workstation. But the better way to go is if you're going to buy 32 gigs of RAM, buy either 2 16-gig DIMMs or 1 32-gig DIMM, and now you have room for expansion in the future, right? Now, there's a little bit of a trade-off you need to be aware of. It's not a major issue unless you're, you know, doing a lot of simulation work. But remember, we talked about the memory bandwidth in the computational workloads. As you populate more DIMMs on the motherboard, you will get better memory bandwidth. So there's a little bit of a trade-off. So I would always recommend you at least populate 2 DIMM slots, and then ideally it's 4 to get the ideal memory bandwidth. But that's not a huge sacrifice. It's only a slight performance gain. So if you're doing lots of simulation, populate all the DIMM slots. Otherwise, you know, you'll be fine with 2. Okay, so now let's take a look at storage. Now, again, if you look at the SolidWorks website, they always recommend SSD storage. And you know, today, it's really actually pretty hard to find a workstation anyways with spinning hard drives anymore. You can still buy them. Really, the only reason to do that in my mind today is if you need tremendous capacity. You know, if you're going to try to make a file server out of your workstation, okay, maybe you would want to buy some spinning drives because you can buy, you know, 4 gig, 8 terabyte, you know, 4 terabyte or even 12 terabyte drives these days. And then you could put multiple drives in your system. You could get a lot of capacity, but you know, that's not really that significant anymore, because most people, if they're storing that much data, they're going to buy a file server, you know, and do that and use, you know, SolidWorks PDM to, you know, manage most of their files there that way. So I highly recommend you look at SSDs, and there's really 2 types. There's SATA-based SSDs and NVMe or PCIe-based SSDs that you can purchase. The main difference is the bus that they're connected. So SATA will be limited at 6 gigabits per second. NVMe is limited at your PCIe bus speed, which is typically much faster than SATA. So, you know, we have drives, depending on which ones you buy, that are 10 times or 20 times faster. So I would always recommend buying an NVMe or PCIe, some people call it that because of the interface, over a SATA-based SSD. And the price now is almost the same. So I would highly recommend that. So again, for standard SolidWorks, usually a 512 gigabyte drive is good. If you're doing simulation, maybe go up to a terabyte because you're going to have more files for that. And then if you're doing visualizing, you're doing lots of rendering, you might want to go up to 2 terabytes. Now, that's also kind of based on where you're storing all your files. Again, if you're using SolidWorks PDM and you're storing most of your files on a central server, then you may be fine with 512 gigs on no matter what you're doing on your local system. You can save most of those files remotely. All right, let's talk about graphics. This is one of the most important features for getting performance with SolidWorks. Now, if you're doing your basic, design assembly work in SolidWorks, then an NVIDIA A2000 or A3000 graphics card is really the sweet spot for most of your work with SolidWorks, okay? And really the great thing that NVIDIA did recently with the latest RTX A2000 and essentially all the RTX A Ampere level graphics that they added was they doubled the size of the frame buffer or VRAM capacity on all of these new cards. So that's really great because now it essentially almost doubles the size of the model that you can load up in SolidWorks without experiencing a slowdown. So these are two really good graphics cards for your standard user. Now for simulation, that doesn't really use graphics at all. That's more CPU centric as we talked about. So the graphics recommendations would be the same. Now, the only time I might say you might want to go a higher level is if you have really large assemblies, right? And the way you can tell that is, look at the memory usage in the Windows System Explorer or use the Dell, some of the Dell tools that we have, the Dell Optimizer, that will tell you how much VRAM you're using on your graphic card. You can tell if you're getting close, okay, maybe you want to upgrade that graphics. Now, if you're using Visualize to do rendering, then that is GPU accelerated. And I would highly recommend if you're doing Visualize work to go up to at least an A4500, if not higher. And if you're doing lots of Visualize work, you can actually put multiple graphics cards in your workstation and almost linearly increase the performance of your rendering. And there's a way that you can even take advantage of a render farm type concept where you can use the graphics cards of multiple workstations or servers to do visualized rendering. Okay, that's a little bit more complicated process. We're not going to get into all the details there today, but I just want to make sure you're aware of that capability. And we do have some workstations there. You can put 3 or 4 NVIDIA GPUs in a single workstation. So it can be a really great solution for doing lots of visualize work. All right, so that kind of covers the general recommendations. Now I'll talk a little bit about some of the performance gains we're seeing in some of the newer systems, and then we'll look at some specific products from the Dell product line. So real quickly here, this is just an example. The Precision 7770 versus the 7760. So this product, the 7770, is the current high-end mobile workstation we offer. I'll show you a picture of that in a minute. And the 7760 is the previous generation, so a year and a half old. And this is the comparison benchmarks that we did. These are SolidWorks spec 3.1 APC benchmarks. And you can see this is the percentage gain in performance between these two systems. So anything that's above a 0, which is right here, the first line, is an increase. And you can see on average we're seeing somewhere around 20% increase on average, but there are some areas like CPU ray tracing, it's 70+%. or CPU composite score, 30+%. Pretty significant performance gains. SolidWorks simulation, almost 20% performance gain just from one generation to the next. And then here's another comparison of a tower workstation. This is our 3660, that system that I was showing you the internals of on the graphic, against another, a previous 2 generations old tower workstation, and you can see, some of the huge, tremendous gains you're getting. So this is basically upgrading your system that was 2 years old, and you're seeing, 140%, or 45%, almost 50% increase in simulation capabilities. So this is pretty significant. So people always ask me, well, how often should I upgrade my workstation? And I know a lot of customers I talk to are usually on a 3-year cycle. But look at the performance gains you can get, even from if you were upgrade 1 year or 2 years. You can always give that older workstation to somebody else to use if you want, but it's really great to see that you can make an engineer a lot more productive by increasing their performance dramatically. All right, so we talked about some of the GPU accelerated capabilities in SolidWorks, and really it comes in 2 parts. Number one, you have your interactive display when you're doing your modeling, your work, you're making changes, you're spinning your model around. So that's one part of the graphics acceleration. And then the other part, of course, is that SolidWorks Visualize. And this just gives you an idea of the performance levels you can see by upgrading your graphics card. So we talked about the A2000 or an A3000 is kind of the sweet spot, right, for SolidWorks. So that's great. But if you go to an A4000 or A5000 on Visualize, you can see how the performance gains you can get. Or ViewPerf, similar performance gains as well. ViewPerf is basically measuring the interactive performance inside of SolidWorks when you're doing modeling. That's the viewport performance is what it stands for. So again, you can see, investing in a higher end graphics card can give you pretty significant benefits, okay, when it's needed. So, there's a number of things that are accelerated here, like the shading performance. This is called FSAA, full scene anti-aliasing, order independent transparency, PhysX, which is the physics engine, and then RealView, you guys are familiar with that, the display engine. And then of course Visualize, and we'll get into a little bit more detail on Visualize in a second. So, making an investment in the right graphics card is really, really important for your productivity in SolidWorks. So as we talked about Visualize, and really what this does, when you're using the Visualize product, turn on the GPU acceleration mode, and it uses all the cores of the GPU to accelerate the rendering. And we talked about the CPU before, and it's not unusual where you can buy a workstation now, a mobile workstation with 16 or 12, 16 cores. Some of those are performance, some of those are hybrid cores, and then a tower workstation, like that 3660 that we're looking at, that can go up to 24 virtual cores, if you will, and then we have workstations that go well beyond that, right? But a GPU will have thousands of cores, and it can be used for specific types of compute operations like rendering, for example. So you can see tremendous benefits. And then also, NVIDIA has introduced this new AI-based denoising technology, which further accelerates the rendering process. And you can see the difference. It may be a little difficult to see on screen sharing, but you'll notice the image on this left side, the denoiser off, looks a little bit grainy. And then the one on the right side, denoiser on, looks much cleaner and smoother. And that's because this can use an AI algorithm to do an image processing on the grainy image and smooth it out. And it can do that a lot faster than doing more rendering iterations. So essentially, you get to a better quality rendering much faster. And some people might say, oh, well, you know, that's kind of neat, but well, you know, is that really going to make a big difference? And the answer is yes, because the reality of it, for those of you that use Visualize or do any rendering, probably know this. When you create a rendering, you're trying to share that within your company, maybe, you know, with your marketing department or an executive to show what the product's going to look like, or maybe even a customer. Then you typically don't render once, right? You have your model and then you add some materials and you adjust the lighting and you render it and you see what it looks like. And you go, oh, I got to make some changes. So you render again, you know, and you're you know, fine tuning it to get it the way you want it to look. So you actually end up rendering many, many times before you get the final render. So this denoising feature and this GPU acceleration allows you to iterate much, much faster. So, you know, really nice feature when you're doing your rendering work. All right, so let's talk about the Dell products, right? So you guys just get an understanding of what the product family looks like, where you want to focus for SolidWorks. So first of all, we offer 3 different types of workstations: mobile, tower, and rack. And then we offer them in 3 different series: 3000, which we consider our entry level; 5000, which is our kind of performance and features, and then 7000 series is maximum performance and expandability. So, and when we talk about workstations for SolidWorks, my recommendations in general, and we'll get into, we have specific recommendations, but again, our, you know, 5000 series for most SolidWorks, you know, interactive work when you're modeling. If you're going to do a lot of simulation and analysis, then you want to look at the 7000 series, because those have more CPU and also for visualization, more GPU compute performance up in this area, right? And then on the fixed workstations or tower or rack, then, you know, 90% of the time you can go with a 3000 series. And I really like the 3660. That's a really great tower workstation. Now, if you're going to do like tons of simulation work, multiple simulations simultaneously, then you might want to look at some of these 7000 series towers. Now, these are very, you know, performant and expandable. So if you're doing, you know, really, really high-end work, for example, you know, this machine, the 7865, can go up to 64 cores. These 2 machines can go dual 28 cores, actually all 3 of these Intel processors. This one's actually a Threadripper here. So, you know, and they can go up to like 6 terabytes of RAM and, you know, 3 double wide graphics cards. So I talk about, you know, if you're doing lots of visualized work and you really want to speed up, you can put 3 NVIDIA graphics card in the 7920. And, you know, it's basically, you know, I'll get almost instantaneous renders in that configuration, right? So, you know, again, if you're really doing some super high-end work, you're looking in this area. But for the most part, you're, you know, in here for mobiles and right in here for tower workstations. Now, I'll talk a little bit about rack workstations just because they're kind of unique. The difference between a rack workstation and a tower workstation is that the rack workstation can go in a data center, right? It will fit in a standard server rack. And the advantage of that is it gets the heat and the noise, and then also doesn't take up any space at your desk, right? It's sitting in a data center or a machine room. And then you just connect to it remotely using like Teradici PC over IP technology. And now you just have your mouse, monitor, and keyboard at your desk. It's connecting through an Ethernet connection, PC over IP, and it seems like the workstation is sitting right there at your desk, but it's back in the data center. So that has some really unique benefits. And it also gives you some flexibility where you can connect to it from anywhere. So you could be at the office, you could be at home, and you could connect to that rack workstation and use it remotely. So that's one of the great advantages of that system. Okay, so all that's great information, but if you want to, dig into even more details, one of the guys at GoEngineer made this really great post optimizing a workstation for your budget for design and engineering applications. The link is here in the presentation. We'll make a copy of the presentation available for you guys later. And you can look at this detailed blog. Also, we have the GoEngineer Dell Expert Network. So this is the great thing that I told you about, to wait to the end of the presentation. So if you go to www.dell.com/GoEngineer, you will get to the Expert Network page, and we're offering a 10% discount on that, on your purchases. So this is an additional discount. So we, Dell already offers standard discounts. This is on top of the standard discounts. So that's a great thing. You just click on this Get Coupon button, and you'll get an email with the coupon, so you can use that for your purchase. Also, we have pre-configured recommendations, and I know these are probably really hard to read on this page, but there's a description here that says, what you're doing with SOLIDWORKS, standard modeling or simulation or visualize. So we have some standard recommendations here, that give you, for mobile and for towers. So you can take a look at those, and you can tweak them if you want. And then, if you still need some help, we have contact info right on the page, and you can reach out to the contact, and they'll get you connected with a sales rep, for your company, if you have more detailed questions or need to know, have a special situation, maybe you need that high-end visualize, rendering workstation. So they can help you configure that as well. We also offer, through the Dell Expert Network program, Dell Financial Services. So if you guys want to finance your IT purchases, you can reach out to Dell, and they have programs to help you do that. It can be really beneficial because you can change, the expense of buying a workstation from CapEx to OpEx. Sometimes that's helpful for companies. Spread out the payments over a longer period of time, maybe, so you can buy a bigger, workstation that's going to give you better productivity. And then finally, I have a number of links in here that I'll share with you. Again, those will be available. If you want to learn more about the Precision Dell Optimizer, that's a tool that helps you optimize the performance for your workstation. It's free to all Precision Workstation users. This is the standard page, Dell Precision Workstations, all the information you want to know about workstations. We have hardware certifications. So if you want to look up what Dell Precision Workstations are qualified or certified for SOLIDWORKS, you can. I can save you some time and tell you pretty much every Dell workstation we offer is certified for SOLIDWORKS. We have the Workstation Advisor, which is another online tool that will give you recommendations. And then we have this Engineering and Manufacturing Industry Guide that talks about overall Dell solutions for the engineering and manufacturing industry, kind of what trends we're seeing in the industry, how that might impact you. And then we have this really great resource. It's called the Advanced Product Development Resource Center. This is a website that has all kinds of engineering and manufacturing or product development resources available for you. So you can read about, you know, the latest and greatest technology in 3D printing, or learn more about simulation analysis workflows, or, you know, how to buy the right workstation for SolidWorks. That's one of the articles up there. And then, of course, this is the link to the GoEngineer Dell Expert Network that we just looked at. So with that being said, I think I covered everything. I'll pause and hand it back to Stephen, and also see if you guys have any questions about anything.
All right, Scott, it does look like we had a couple questions in the queue. One of them asks, would it be, when will it be simple to monitor the CPU temperature on the Dell machine?
Okay, there is a tool that I talked about, which is the Dell Precision Optimizer, that will let you analyze that. It will give you a chart showing you actually not only the CPU temperature, but the GPU temperature as well. Now, there's some other tools that you can use, you know, some of the Windows tools, and there's even some Intel tools that you can download. Or there's another one called GPU-Z. I don't know if you've heard of that technology, that application. That's a really great one. I use that one a lot, actually. That will let you, you know, analyze the GPU and the CPU temperature as well.
Okay, perfect. I think that's about it.
That's it.
If I don't see any other questions in the queue.
Have any other questions, you can type them in, or I think you can ask to maybe be on audio if you want. All right, well, if there's no other questions, we really thank you guys for joining us today. I hope all the information was useful. And again, we will make the slides available for you to download. Everybody,
thanks,
have a
Scott.
great day.
Thanks, everybody.
Bye, guys.